So today the topic is excavating the building site. So I'm going to go through a workflow. So I've done a quick sketch here just to give you an idea of what I'm planning on doing. A workflow of, we've got stakes on a parcel of land that a surveyor's put in. Then we've got an excavator coming, he's going to excavate the land, and we need to relocate our building. So there's a road alongside, we've got a building, and we've got our excavation pit. So that's the sort of situation that we're dealing with here. In terms of what's actually going to happen workflow-wise, I'm going to go through a control line setup. I would want to perform a height transfer as well, so we have 3D coordinates. I want to show as built, and I'll do a layout point function as well, or stakeout. So I'll just go into the situation a little bit more, into the workflow. So this would be, I guess, just a very simple 4 stakes on a parcel of land that the surveyor's put in. Once I've done a control line setup, and I'll explain what that is later because some of you may not know. Once I've got a control line setup, I can get the coordinates of the points, but I'll only get them in 2D because the control line setup only gives me 2D coordinates. So I need a height. Most of the time you'll see something similar to this, either on a lamp pole or on a wall or something like that, and that is a height that a surveyor has put in, and I'll explain heights a little bit more later as well. But so then you get your height from a mark like that, and you'll be able to have 3D coordinates. And so eventually then when the excavator comes and he's dug up the land, you'll be able to locate or relocate your building with 3D coordinates in the right position again. So, and I'm in my as-built function. So I mentioned the control line setup, and I'll just explain that briefly. It's basically a lot of foremen on site will use a control line setup because they're unfamiliar with setting themselves up using coordinates. So this is more like a local setup, so you position yourself 2 points along something that you know will remain there for the entire duration of the project. So you might have a wall from a building that's adjoining your site or adjoining your lot, so you know that that building is going to stay there. You might have a road, like I showed you in my sketch before, that you can measure 2 points off and you know for sure that that road is going to stay. So that way you can always position yourself locally, and that's sort of, it's what a foreman tends to use a lot. And as I said, it gives you then the 2D coordinates. I will perform a control line setup now. I went down here into the setup function, and it gives me all my different setup options. There'll be a session later on as well with, where I will go through all the setup options that we've got available. So under control line, we've got anywhere. So it means our total station can be anywhere, and we have, like I just mentioned before, 2 points along a wall, along a road. So I'm going to choose anywhere. I've turned my compensator off for this because it's just going to keep telling me that I'm out of level. So normally you'd have your compensator on. At this point then you would level your instrument. And this is obviously giving me a message telling me that the compensator is off, so no, I don't want to turn it on. And it's going to measure my start point. I will do that now. And it's given me my first point. And as you can see, we've got the wizard alongside here, so it gives you the steps, step by step, telling you what to do. Measure my second point. So now we've got point 1 where the green flag is, and point 2 where the little finish line flag is. So telling me up here that the control line is defined and the origin and orientation will be set. So I will accept that with the green tick button, telling me my setup is finished. So now you can see where my total station is positioned in relation to what I just measured. So I just measured along the wall in the room here, so that's my control line. As I said before, these are points that have 2D heights. So I want to show you how to get a 3D coordinate, so how to get a height in your station. And that is done again in the setup. And under transfer height anywhere. So I'll just bring up something else here in the room. As you can see here, I've drawn a height in the room. So it's just an arbitrary height, really. I've just drawn something on a whiteboard. There you go. Thank you, Bound. You can see the numbers there. I've written 420 metres 50 ASL, so that means above sea level. Obviously, we're in Switzerland here, so it's going to be a little bit higher. And the bottom one is 1 metre FFL, which means finished floor level. On a building site, most of the time, they'll be working with the finished floor level height. So that means that somewhere there'll be a 0,0 height, and that would have been done by the surveyor, and that will be in relation to the ASL, so it's still to the sea level. And then any height thereof is going to be a derivation, if you will, from the 0,0 height. So you'll have your 1 metre finished floor level height. You can enter a reflector height here if you want. I don't need to do that now. And it's telling me to measure a reference. So you can see now that I've turned my laser pointer, so I'll just show you again. Turn my laser pointer onto the mark, and I'll enter the value of 420. And I'll accept that. So now I'm focused on the point. I've got my height entered. I measure it. At the top here now, it gives me my new station height. So now we have a height now for our station and for any coordinates that we want to measure or stake out afterwards. I'll accept. And my setup is finished. It's now giving me a height. Now I'm going to measure a few points in the room. I'm just going to do 4, just do a very basic building. So to do that, I'm going to turn my measure mode on to continuous, so you can follow what I'm doing. We'll start. So that's the point there. So on the next point. And that one. Here we go. So now you can see I've measured the 4 corner stakes. So again, try and imagine that we're out on the field, and I've put my prism on the stake, and I've measured to my prism. Now I've got the point. Just as a little side function, just relating back to what I showed you last time when I gave my demo, is you could go into sketching now, and you could connect the points. So I want to connect multiple points. And I'll select point 1, point 2, point 3, point 4, and close this again. So now, there you go. Now you can see our control line, and you can see that I've measured 4 points of my build. So imagine now that the excavator comes and he excavates the land, and you're left with nothing. Obviously, everything's gone, all the stakes are out, and you'd like to relocate your building again. So for this, we're going to stake out. Now normally, then you'd have your job already saved, and you'd be able to load the data in from that job, and that'll be another session at some point. Is going to be import and export data. So I'll show you how to bring the data from that job into a new job, for example. And now we'd like to stake out some points. So then, obviously, when you relocate yourself, you would use the same control line again to set up, so that you're obviously locally measuring to the same thing. The important thing is obviously that everything fits within itself. So, and that'll be the case if you use the same control line. Now, I've got a robotic total station here. So to make it a little bit quicker, I have a function here called turn to point. So if I click on that, it says pick point, and instrument turns to select the point. So I want to choose, for example, point 1. And I say yes. And you can probably hear that my total station is moving. And it's pointing in the right direction. So it now tells me where I am once I measure to it. There we go. So obviously I'm going to be right on the mark there at 0, 0, but you can see that then it switches to the bullseye view again. It gives me a little green point here saying that I'm within the tolerance. So I can store that point comfortably, and I get a green tick. Obviously, if you don't have a robotic total station, you could still do it manually, the way that you're used to doing it. No measure. And that's telling me that I'm 2 millimeters off. So that's good enough for here. So I'll store that. So again, it's easy. I won't go through all 4 points here just to save some time. But so very easy to relocate your building, very easy to do a control line setup, very easy to do a high transfer. So basically your whole building workflow is done very simply. Just as a last little thing here, I want to show you the excavation pit. So this way, so for example, a surveyor might have come in and he might have measured up the edge of the excavation pit to make sure that it's been excavated, far enough, or that it's big enough or deep enough. So you might have a file given to you from him, which then you could reference in again like this. You could also see, are you in the right position? Are you far enough away from the wall? So for example, in this case, it doesn't look like it would pass. It looks like I'm way too close to the wall here. So that way, yeah, it's also a good check for you. And if he's given you points, you can very easily then stake out his points again if you need to do that. So that more or less, I guess, covers the workflow.
I actually think it would be nice if we also could show, for instance, in this workflow, once the excavator has done the pit, then obviously the guy in charge would like to know from his height benchmark, from his reference, how deep he needs to dig actually. So how deep he needs to go down with his excavator to see where the bottom is of the pit, to make sure that the elevations are correct. And I think that would be nice to demonstrate actually. From that reference we were using here in the room, let's say the excavation pit from this reference, just in theory, has to go down something like 1 meter or so. In this case here, just for reference, and then we could show actually in the screen how we see that.
So I've measured to a point which is below the point that I've staked out and I've measured. So it gives us the height in relation to the height that we've stationed. So it tells you then the difference up in the height here. So I know now that I'm too low, or that I'm lower, or I need to go lower. So again, if you were the excavator, you'd be able to work off that.
So often the foreman on site, he knows exactly how much from his height benchmark, so from the 420.5, he knows exactly how much he needs to dig down. So he can either monitor here and knows, let's say, from that benchmark, I need to go down 3 meters, so he would end up at 417. So he needs to know then, okay, from here I need to go down a bit further. Or actually, when Tasha showed you the height transfer, you could enter, instead of the ASL, the sea level, you could enter the finished floor level, which would be then, let's say, 1 meter. And from there, again, the foreman would know how much to go down from the finished floor level, which is then, for the instance, for a cellar, he would go down 2 or 3.5 meters or something like this, and then easily could check this value again in the info panel. So he knows exactly how much he needs to go down. So that would save the often difficult task of doing this with a rotating laser when you're working on a slope, for instance, and this is really tough, or with a plumb bob or something like this.